And today's guest is the one, the only, Ray Kurzweil. He's an author, he's an inventor, he's an innovator, and this is our conversation. Ray, welcome to the show.
Great to be with you, Neil.
Yeah, so let me just up front say I'm probably your biggest skeptic, just so you know. That's what you got. So you ready for this?
You're probably not the biggest skeptic.
So I'm going to pretend like we're just at a bar, just arguing. First, I'm angry with you for taking our word singularity. That word had a perfectly good use, perfectly fine definition. It's what happens at the beginning of the universe and in the center of a black hole, and you had to go up and name it something else.
Yeah, well, John von Neumann actually came up with that.
Okay.
He said history is approaching a singularity because progress is accelerating at an exponential pace, and it's going to reach a point where progress is so fast it's going to be a singularity in history.
This is John von Neumann, the computer,
Yeah.
Computing pioneer.
Yeah, he invented the architecture that all computers use today. Although actually Babbage invented it a century earlier, but John von Neumann...
The Babbage, it was a machine he invented. Yeah.
Babbage created a mechanical computer that never actually worked, but it actually had the architecture we use today. John von Neumann derived it independently a century later.
So what's your background, actually, just so I get some sense of this?
Well, I decided I was going to be an inventor when I was 5, and discovered the computer when I was 12. Not so amazing for 12-year-olds today, but there were only like 12 computers in all of New York City.
You're a native New Yorker?
When I was 12, yeah. I was actually...
So I have to ask you what high school you went to. I have to ask you.
Martin Van Buren High School.
Martin
But it was
Van Buren.
actually IBM 1620 at Flower and Fifth Avenue Hospital in Spanish Harlem, which I had the midnight to 8 a.m. shift.
As a what?
I was programming.
So you were a computer person for the hospital on that computer?
Yeah, in fact, I created the statistical tests that we use to evaluate the Head Start program,
Oh, wow. Okay.
like analyses of variance and so on.
Wow. So you go way back.
Yeah, well, it's only 50 years.
Okay. You go way back in a human lifetime, not in a cosmological timescale. So at what point, you wrote a book called The Singularity. It was,
The singularity is
back in
near.
This is what, like, cult leaders, the end is near.
Well,
back in 2006, you write this book.
It is a play on the end is near.
Okay. What did you predict at that time?
Well, actually, going back to a book I wrote in the 1990s, The Age of Spiritual Machines, I predicted that
The age of spiritual machines.
Yeah.
Okay.
by 2029, computers would have all of the intellectual and emotional capabilities of humans, and so they would be spiritual machines. And conversely, we are spiritual machines because our brains are composed of 300 million modules that recognize patterns. Each of those modules has 100 neurons. Those neurons have ion channels and dendrites and axons, and basically you can describe, based on physics, which you know
The
a lot about,
electrochemical pathways.
how they work, and we can actually model them, and we are modeling and simulating the brain today, and they are, so each neuron is a machine. Very few people would disagree with that. Well then, you know, the 30 billion neurons in our neocortex is a machine also. And actually we can understand it. My most recent book, How to Create a Mind, talks about how that machine works.
That sounds diabolical. How to create a mind. What's going on in your basement? You can tell me. Nobody's looking. Tell me.
Well, we are understanding how human intelligence works. I mean, these things are brain extenders already.
Yeah.
We are
the smartphone that you point to.
Our brain is already expanded in the cloud. We're smarter as a result. We'll directly connect our neocortex in the 2030s.
But wait. Let me.
Well, the last time we did that was 2 million years ago when we went from primates to humanoids, and we got these large foreheads. And we had the frontal cortex, which is where we do language and art and science and physics and radio shows. No other species does that. But it's not qualitatively different. The frontal cortex is actually was just an additional quantity of neocortex. The neocortex is organized in a hierarchy, and we took that additional neocortex and put it at the top of the hierarchy. And as you go up the hierarchy, things get more abstract. So things like music and poetry exist at the top of the neocortical hierarchy. And we're going to add to it again by connecting our neocortex to the cloud and to synthetic neocortex and expanding it's the way we did 2 million years ago, except this time it won't be limited by a fixed enclosure. We'll be able to expand it without limit.
What's the difference between extending the power of your brain through some connection into silicon-based intelligence versus just having access on your hip to all of that extra knowledge and
I think
intelligence?
there's no substantial difference. I mean, I think this is a brain extender.
Because people talk about, plugging some USB port into your...
Well, the scenario I think that is realistic is computers are getting smaller and smaller. We'll have nanorobots at the size of blood cells that have computers in them. They'll go into the brain through the capillaries and communicate with our neurons. We already know how to do that. People with Parkinson's disease already have computer connections into their brain. That will communicate wirelessly to the cloud. This computer on my hip communicates wirelessly to the cloud. It can multiply itself 10,000-fold by accessing thousands of computers when we need them in the cloud. It can access millions of computers of information. So a kid in Africa with a smartphone is accessing all of human knowledge with a few keystrokes by connecting wirelessly to the cloud.
But then why invoke the brain-machine connection at that point? Who cares? You got the machine.
Because it's a much faster interface. I mean, our fingers are very slow compared to... we could have, millions of...
I didn't know the world was going too slowly for you. You want to speed it up. Okay.
Well, it is. I mean, how long does it take you to read,
To read and write?
The Brothers Karamazov. It takes, months.
So you're suggesting that you can get these nanobots the size of your neurosynapses, let's say, and one will be preloaded with War and Peace, the novel, and would somehow injected into your neurosynaptic memory banks, and then you're done. You've got it. Just like in the Matrix, they would load memory programs into you.
We will connect to neocortical hierarchies in the cloud. Some of that could have preloaded knowledge. We could communicate with each other more intimately that way. But basically, we'll expand the size of our neocortex. And that's, what's the difference between a mouse and a primate is the primate has more neocortex. It's therefore smarter, can master more levels of abstraction. And when we got these large foreheads becoming humanoids, we had more, and that was the enabling factor for us to invent language.
So the wireless cloud becomes the growth of our neocortex,
right,
into the next dimension.
We'll have the
next
opportunity
phase.
again to grow our neocortex. And once again, we'll put that additional neocortex at the top of the hierarchy. And as you go up the hierarchy, the level of abstraction gets greater. So music and art and poetry and radio programs all exist at the top of that hierarchy. At the bottom of the hierarchy, I can tell that rug on the floor is a straight line and very simple things like that. It's the top of the hierarchy where the interesting things happen. And we have not been able to expand it for 2 million years because we have this fixed enclosure. That was very clever.
Our heads are not getting bigger because you kill the mother being born, and it's a bloody mess. So I think we've maximized the size of our head.
Yeah, well, that's right.
Given the size of the birth canal.
And that's the reason that we've not been able to expand it anymore. In fact, it was quite a challenge to expand it 2 million years ago.
Even to what we have today.
Yeah.
So why the precision in your prediction, 2029? That sounds audaciously precise.
Well, there's one thing that's surprisingly predictable, which is the pace of the exponential growth of information technology. The price, performance, and capacity of information technologies like computation, communication, now biological technologies like sequencing and also simulating biological processes, the amount of data we're getting on the brain, many different measures, not of everything, but of information technology, follow amazingly precise trajectories. And
Growth trajectories.
right, and they're exponential. So I mean, I was looking, actually it was 1981. I realized that timing was critical to being successful as an inventor. It's also true for anything else you might want to do, doing physics or romance. I mean, you got to be in the right place with the right idea at the right time. So I started with the common wisdom that you cannot predict the future, and I made a surprising discovery. Lots of things are unpredictable, but if you look at the price, performance, and capacity of information technology, like, for example, the price performance of computing, calculations per second per constant dollar, it follows an amazingly predictable trajectory, going back to the 1890 American census. And so I actually projected out those curves that I had in 1981 I had them through 1980, through 2050. We're now in 2015. It's been more than 30 years later, and it's exactly where it should be.
You're on the line.
So
You're still-
that aspect of the future is amazingly predictable. I predicted we'd need search engines in the late 1990s. I made that prediction in the early 80s because I saw the ARPANET, the predecessor to the internet, expanding exponentially.
Yeah, one of the great jokes that was only a joke for 6 months was the internet is the world's greatest library, except all the books are scattered on the floor. That was before search engines came in. And within a couple of years, search engines came, and now that reference doesn't even work.
Right. Well, I saw that we did have a need in the late 1990s for search engines because there'd be so much knowledge on the web that we couldn't find anything. And we'd have the computation and communication resources to do a good job with that. What I was not able to predict, and what we can't predict, is that of the 50 projects to do that, it'd be these couple of kids in a Stanford dorm who would take over the world of search. So not everything's predictable.
This would be Google, yeah.
I wouldn't have to work very hard if I had made that prediction. And actually took my first job ever, at least for a company I didn't start myself.
I was wondering if you actually ever had a stable job, or you're just riding on your...
Well, that's a stable job for a pretty unusual company. This aspect of the future is very predictable. If you measure the capacity and price performance of these different information technologies, computation, communication, biological technologies, technologies having to do with the brain, they follow these very predictable trajectories. One of the reasons you might be skeptical is it's not intuitive. Our intuition is linear. And so the difference between myself and my skeptics or critics is we're both looking at the same present, and people then apply their linear intuition about the future. I mean, if you wonder...
No, I can think exponentially. I'm skeptical for different reasons than that, but go on. I'll get there.
Well, you know,
You're not gonna get a
if you
free
wonder
pass here.
why we have a brain, it's to predict the future. But the kind of challenges we had, 50,000 years ago, when our brains were evolving, were linear ones.
We have no exponential training at all.
We
I
track
got
an
you.
animal in the field, and we don't expect it to speed up as it goes along. We expect it to go at a constant pace. That worked very well. That became hardwired in our brains. That's our intuition about the future. And a linear progression, that's our intuition, goes 1, 2, 3. An exponential one, that's the reality of information technology, is 1, 2, 4. It doesn't sound that different, except by the time you get to step 30, the linear progression, our intuition, is at 30. The exponential one is at 1 billion. It makes it very
Proud
profound.
of me for knowing that? 2 to the 30th is 1 billion. I got that.
That's good. That's good to know.
I know, I got you on that. My skepticism comes from a different place.
Okay.
But so here you go. So you're right on the curve as time goes on. This gives you confidence in your modeling. And so now you say 2029, what happens?
Well, actually, somewhat before that, we'll have the computational capacity to functionally simulate the human brain. So that's a whole discussion of what is the capacity of the human brain. And there's actually been derivations using different methodologies, all of which come to the same results. It's about 10 to the 14th calculations per second to functionally simulate the brain. That doesn't mean simulating every molecule. It means basically...
10 to the 14th is a huge number. That's huge.
It's pretty big. I mean, our supercomputers now surpass that. They're up to 10 to the 16th, 10 to the 17th. But we'll have...
I guess in our own, when you're sitting there just watching the ball game, you're not thinking you're going through 10 to the 14th calculations or thoughts per second.
It's all happening simultaneously.
Yeah. It's not an active thought that our brain is that active. That's all.
Well, it does have tremendous capacity, but it's also limited. We have these 300 million pattern recognition modules in our neocortex, and that's a lot from one perspective. That was enough for humans to invent music. I mean, no other animal can keep a beat. No other animal.
Some humans can't either, just to be clear. Okay.
I've met a couple who could, but it's also limited. We have expanded it to some extent by connecting, at least indirectly, with devices.
Right. So you project to the future, some point where computational ability and storage.
Well, computation's one side of the question. The other is the software side. That's a more complicated analysis, but our information about how the brain works is also growing exponentially. The spatial resolution of non-invasive scanning is doubling every year. And a lot of people say, well, it's so complicated because there's just billions of different connections, ignoring the fact that there's a lot of repetition and redundancy. There's actually 300 million modules, and they all work pretty much the same way. The neocortex, people thought, oh, that must be very different because that does art and poetry, compared to, let's say, V1, which can tell that there's a straight line in front of me. But it actually turns out to be the same algorithm. But they're organized in a hierarchy, and we put that additional neocortex capacity into the top of the hierarchy. And there are descriptions today. I have one in my book, How to Create a Mind, of roughly, functionally, how the human brain works, how the neocortex works. That's where we do our thinking. We're going to refine that as we get more and more information about the brain.
What's the downside?
So we're going to keep moving in that direction. And I believe we can have a world that's essentially free of poverty, where disease has been greatly reduced, clean up the environment, have plentiful resources in terms of energy and food. And the downside is, I mean, there's lots of movies about the downside.
I don't need you to tell me about what the movies do. All right.
Where, you know, the AI is trying to destroy humanity, and it's the humans against the artificial intelligence or the robots, or it's two groups of humans fighting for control of the AI. One thing that gives me comfort is we don't have one or two AIs in the world. We have 2 or 3 billion AIs. I mean, a smartphone is an artificial intelligence. It's in fact very intelligent, and it accesses the cloud and makes it even more intelligent. And it's in billions of hands. People say, oh, only the wealthy are going to have these technologies that Kurzweil talks about. And I say, yeah, like smartphones, where you in fact had to be wealthy to have a phone, a mobile phone. It wasn't very smart, 20 years ago. And it didn't work.
Only the cool people had mobile phones, like Gecko in Wall Street. There's the famous scene where he's walking on the beach and he's got that sort of shoulder-mounted mobile phone. And I remember seeing that, I say, wow, that's really cool. He's so rich, and he can just walk down the beach with a phone on his shoulder.
And it really didn't work very well. And today they do a million things, and they work much better.
It's just incidentally a phone, right?
And there's billions of them. I mean, there'll be.
So what of all this talk, whether or not you initiated it, about uploading one's brain to a computer and then the computer becomes you? What do I make of this talk?
Well, that's not really the scenario I think will happen. We've already talked about how we're going to connect to artificial intelligence. Now, we do that mostly indirectly. There are a few people that have computers connected in their brains, like Parkinson's patients, but for the most part, they're not inside our brains, but they may as well be.
So what do you predict will happen in society the day that occurs?
Well, it's not one day. I mean, first of all...
Of course it's not a day, but just...
The predictions I made for today, 30 years ago, people thought were totally ridiculous. Now that it's here, we can't imagine that it ever wasn't the case. Did we ever have a time where there wasn't social networks and mobile devices where we could access all of this knowledge and each other and so on? That was only a few years ago. And so by the time these things happen, we actually get used to them, and they become ubiquitous very quickly, and we forget that it ever wasn't the case. I mean, you can now talk to your computer and ask it questions in natural language. The thing is, when these capabilities emerge, they're kind of clunky and they don't work very well, so people dismiss it saying, well, it doesn't really work. Then by the time it does work well, people say, well, it's been doing that for a long time. It's nothing new. And so it kind of creeps up on us. Computers, we're going to be talking to them, and they're going to get more and more sophisticated, and very gradually they'll become more and more human-like to a point where they're really indistinguishable. And so, 100,000 years ago, we couldn't reach that fruit at that higher branch, so we invented a tool that extended our physical reach. And then we invented tools that expanded our muscles, and we could create pyramids and great buildings. Now we can access all of human knowledge with a few keystrokes. We're always expanding our reach. That's actually what's unique about humans.
And I remain fearless of that, because when you look at machines replacing, in the Industrial Revolution, replacing physical labor, and you look at computers replacing computational labor, the day we lost to Deep Blue in chess, our best chess player loses to a computer at a game that we invent. And then our best Jeopardy player loses
that was more
to
significant,
Watson.
Because that was language. Jeopardy got this correct.
Language and cultural knowledge.
Yeah, Jeopardy got this query correct in the rhyme category. A long, tiresome speech delivered by a frothy pie topping. And it quickly said, what is a meringue harangue? And that's pretty impressive.
Wow.
And Jennings and Rudder didn't get that. And Watson got a higher score than the two of them combined. They're the best players in the world. And it got its knowledge not by being programmed with all this information by the engineers, but by reading Wikipedia and several other encyclopedias, 200 million pages of natural language documents.
All on its own.
Yeah.
Yeah, so I guess I don't fear it because it's already happening. Like you said, it happens. It's not a cliff.
We're on that road, and
It's a road that we're on, and I see it, and I embrace it actually.
it's a good road. I mean, if you compare human life today with all of its problems, it's far better than it was in the past, and it's going to keep moving in that direction.
Good road to be on, and you help us predict what the road signs will look like.
Working on it.
Right, it's been a delight.
Yeah,
It's been delightful.
definitely.
So you have cured me of my skepticism
Good.
of where you're coming from and where you're going. Until I see your basement, I want to know what you're working on.
Well, you'll never see that.